Please take your seats. Our program will begin in 15 minutes. welcome Meta Chief Product Officer, Chris Cox.
All right, welcome everybody to LlamaCon. It's an honor to be hosting you all today. It is crazy to think that 2 years ago, open source AI was a dream. I remember the conversations we had internally when we started talking about this. People were like, you guys are nuts. There was this financial question, does it make sense to spend all this money on training a model and then give it away? There was this priorities question, is this going to be a distraction to focus on developers and open source instead of just training the best model and putting it in our products? When we started talking about it externally, it was just like, this is bad. This was like peak AI doomer 2 years ago. Everybody said open source is going to fall into the hands of bad guys. There was not a lot of imagination about all the good that could come of it. There was the safety and security questions. There was the performance question. Could open source ever compete close to the frontier of the closed labs? But we were in touch with the startup community. We were in touch with developers. We were in touch with entrepreneurs like everybody here. And I mentioned this up here last September, but we were a startup once too. I was at the company when we didn't have a lot of financial resources. And we wanted control over our own destiny. And we built this place on open source. And from the very early days, a lot of our best engineers were contributing back to the open source stack that we were built upon, or becoming primary authors of new open source projects in the web stack, and then over the years, the mobile stack, and then over the last decade, the AI toolkit we build upon today. So it is great to see now that open source is cool. There's general consensus in government, in the tech industry, among the major labs that open source is here to stay. It is an essential and important part of how AI will be built and deployed. It can be safer and more secure, just like Linux, because it can be audited and improved in broad daylight. It can be performant at the frontier. And most importantly, it can be deployed and customized for specific use cases, for specific types of applications, and specific types of developers like the folks here. The groundswell of support for Llama has been awesome. We announced 10 weeks ago 1 billion downloads after the release of Llama 4. In just 10 weeks, that number is now 1.2, which is exciting. And what's cool if you look at Hugging Face where the downloads are happening is most of these are actually Llama derivatives. We have thousands of developers contributing tens of thousands of derivative models being downloaded hundreds of thousands of times a month, fitting into the specific types of applications, nooks, crannies, language support, and use cases that are happening that everyone here is building. This is thanks in part to the awesome partners that we have. Thank you to everybody here. We appreciate the fact that regardless of your development environment, you can get started in using Llama right off the bat. It's a lot easier to plug and play specific parts of your applications because of the Llama stack. A lot of partners have implemented this. That means that you can choose the best parts of the solutions. They're modular. It's easy to switch between component parts. This has made development a lot easier. When we started thinking about Llama 4, we were very focused on the things we heard from the community they care about most. A lot of performance in a very small package. This is our very first MOE model, which means you're getting more performance in a smaller binary and a smaller set of weights. It's also the first open source multimodal model, which means that photos and text were trained non-natively, so it's fast against visual use cases. It's massively multilingual, supports 200 languages natively. We use 10x more multilingual tokens than Llama 3. And it's got a huge context window. You can put your whole code base in the context window. You can put the entire US tax code in the context window if for some reason you have a very complicated tax return. In this case, we took all of the code for SAM2, which is our object segmentation model, and asked to write a get started guide, an FAQ for new engineers, which it did extremely well. Needle in the haystack is good. It's a key bread and butter use case for large context windows. We're working on instruction following and latency, which are the areas we've heard about the most. For visual reasoning, quite good, especially again at the key tasks like OCR, PDFs, charts, and graphs. We know a lot of you are working on visual domains. This was a huge ask of us, and one we're committed to improving. And then again, the most important thing was make it as small as possible. Get as much intelligence as you can into the smallest possible model, because we're building businesses here. We're running them at scale. So our little guy is Scout. That runs on a single H100 and is best in class on a number of benchmarks for a model of its size. Llama Maverick is the next biggest. This is 17 billion active parameters. It runs on 8 GPUs. Most of you will be doing this distributed. This is what we're using in production for a bunch of our products, including Meta AI. And we got to good performance here by using a teacher model, which is Llama Behemoth. This is absolutely massive, one of the largest models out there. Yeah, that's what he looks like. And again, this teacher model is how we got to good performance on Maverick. And again, a relatively small package. When we look at the stats, we're most proud of price per performance. That's cost per token, as well as latency that you get in small sizes. That's time to first token and throughput in terms of tokens per second. These are the benchmarks along with intelligence. Here we're using a composite, which is artificial analysis blend of a bunch of key OSS benchmarks that really measures what we know most of you care about, which is as smart as possible in as low as possible a cost and as fast as possible at the speed. Again, this is how we can deploy this stuff at scale if you're running a business, whether it's small or whether it's large like ours. We're using this stuff to power Meta AI, which is used by almost 1 billion monthly users across WhatsApp, across our other apps, and standalone experiences on our Ray-Bans. This is what we're using at scale. And we've customized it for the specific use cases, each of which you have as well, that matter to us. For us, that's conversationality, it's brevity, especially if you're on the go. It's humor. And speaking of Meta AI, we announced an app this morning, which we launched. So we wanted to focus on pushing the limits and a fresh take on how people could use AI. We were very focused on the voice experience, the most natural possible interface. So we focused a lot on low latency, highly expressive voice. The experience is personalized, so you can connect your Facebook and Instagram accounts, and the assistant will have a rough idea of your interests based on your interaction history. It will also remember things you tell it, like your kids' names and your wife's birthday, and all the other things you want to make sure your assistant doesn't forget. We added an experimental mode, which is full duplex voice. This means it's trained on native dialogue between people in speech. So rather than the AI assistant reading a text response, you're actually getting native audio output. And full duplex means that the channels are open both ways so that you can hear interruptions and laughter and an actual dialogue just like a phone call. So it's pushing the limits, what we think of what's possible with a natural voice experience. It's early. So the duplex mode doesn't have tool use, it doesn't have web search, so you can't ask it about NBA trades and like the papal conclave. However, it's a very interesting way to see what's possible at the frontier. We also wanted to make this fun, and we know a lot of people getting started with AI have no idea what to do with it, and it's not until they see the way that others are using it, doing stuff like them, that they get inspired. So whether it's homework or creative writing or AI artwork or code, the community is actually quite mimetic in that we learn from seeing each other do it. So we put this right in the app. You can share your prompts. You can share your art. It's super, super fun. We've really been enjoying prototyping this because it makes the experience a lot more creative and a lot more social. And then the last piece we focused on is pairing with your Ray-Bans. These are incredibly popular. They're the ultimate AI device of today. They're multimodal. You can ask questions about what's in front of you. Again, it's a voice interface. So the app focuses on taking that and making it coherent, whether you're using the glasses or whether you're just using it with your phone. So in terms of evals, we, like many of you, have been very focused on understanding use cases and understanding user value. That's, I know, for each of you, a big question is how do you make that stuff really good? We've actually seen a bunch of partners here doing really amazing things. I wanted to highlight a few of what I think are some of the most inspiring that showcase what's possible with Llama. Starting with local deployments, the ultimate local deployment is a Llama in space. Booz Allen and the International Space Station are running a version of Llama 3 that makes it easy for astronauts and scientists on the International Space Station to make decisions based on tens of thousands of pages of documentation and manuals to figure out what button to press. And they can do that without a connection to Earth. If the connection's absent or super, super, super high latency, this gets them something local that's quite good. Privacy matters a lot, especially in the domain of medicine and healthcare. We're seeing a bunch of really interesting work happening here. Here you see Sofia, which is a Latin American medical provider. They've already seen really good results on helping doctors spend less time on paperwork. We've seen similar work from the Mayo Clinic, who's done this in the domain of radiology, made it easier for doctors to diagnose and understand complex cases instead of spending time rummaging through massive amounts of literature. The regional examples are very interesting. Farmer Chat is a sub-Saharan African tool for farmers in agriculture who can spend time getting real-time information to understand what to do with their fields. This has language support. It's been really popular, and again, they're getting great results. Kavak is a used car marketplace that's in Latin America and the Middle East. Similar example where you're getting really good results at a customer support use case that's focused on a specific region with a specific type of content based on really good fine-tunes. And we're seeing big folks using it too. AT&T told us that they're taking the daily transcripts of all of the customer support calls and putting them into a context window so that they can generate basically top 10 lists for what their engineers need to focus on that day to fix bugs. And again, really, really good results from switching to an open source model because they can customize it specific to the things that matter to them. The models getting built on top are awesome. NVIDIA's Nemotron is focused on reasoning and agentic use cases built on top of Llama 3. Again, we're really excited to see the energy around this deployment. Enterprise use cases are telling us pretty good things about switching to an open source model in terms of delivering results for enterprise customers who care about data security. This is Box. They have 100,000 active customers. They announced a partnership today with IBM, which is going to allow them scale to a lot more. So we're continuing to ask what we can do to make Llama better for you. With Llama 4, much like with Llama 3, we expect that the dot releases are going to deliver a lot of value and are going to let us burn down the list of what you're telling us we could do better. Starting with model performance and quality, most important, instruction following, et cetera. Cost, keeping it as affordable as possible, making it as fast as possible, making it completely customizable and steerable to do what it is that you need to do with your tools. And of course, making sure you're not locked in. Not locked into Llama, not locked into specific building blocks, being in control of your data, not having APIs changing out from underneath you, having control of your destiny. Also, a lot of feedback on ease of use, which we're continuing to work hard on. Today, we're announcing that you can now start using Llama with one line of code because we're releasing an API. I'm going to invite up Manohar Pillari and Angela Fan, two of our very first Llama engineers, to walk you through how that works. Come on up, guys.
Hi, everyone. It's amazing to be here with you all today.
Yeah, it's great to be doing this together, Angela. And what a crazy ride we have had since we started building Llamas together.
Yeah, when we started making Llama 4, we reflected a ton on the feedback from you all in the developer community on things like new capabilities we should add, improvements that we wanted to make, and we heard things from multimodal support to increased efficiency in the base model.
we couldn't take an incremental approach to Llama 3. We had to take a step back and look at some hard technical decisions we had to make for Llama 4, and each one came with different trade-offs.
A really early one that I remember we debated was just the architecture itself. We had been working a lot on dense models. We had a lot of experience with this. It was simpler and to configure, easier to parallelize, but should we make the jump to sparse?
And Llama 3 model family was dense, and we knew dense had its drawbacks, and we had to think about alternate architectures.
Yeah, exactly. Dense models, they can be really compute inefficient, and as we train more and more models and develop more products, a lot of this training inefficiency hit us pretty hard. And so we ended up going with sparse. There was, of course, all that added complexity in some of our deployment and our training, but we got a lot of wins in performance, efficiency, and cost.
I also remember the technical bet we made on distillation. Llama 4 Behemoth was a 2 trillion parameter model, which packed a lot of intelligence, but it is harder to run at scale. So we used it as a powerful teacher to improve the performance of Maverick at the same price.
Another one that I remember is incorporating multimodal, right? Early or late fusion was a discussion we had. So when we first started taking Llama 2 and trying to expand out of the text performance of that towards Llama 3 by adding the image capability, we had kind of frozen the text model of Llama 3 and added on image by adding adapter layers. This was very straightforward, and it made for a very modular system.
But with Llama 4, we wanted it to be natively multimodal. So we took a step back and changed the training recipe. We started with text training, interleaved other modalities, and this allowed Llama 4 to be cross-model training, which made both Scout and Maverick much better across all modalities. I think we can keep going on the numerous technical decisions we made in building Llama 4. But we are excited today to talk about the API. Our goal from the beginning for Llama 4 API has been it should be the fastest and easiest way to build with Llama. Not only that, as you saw, the derivative models, it should be the best way to customize these models. And going one step further, you should be able to take these custom models with you wherever you want. No lock-in ever. Speed, ease of use, customization, and no lock-in are the marquee features of the Llama API.
And we handle all of the inference and the infrastructure work, so you all can focus on building your products, what you care the most about. We want to deliver the best performance and the features that you would get using closed model APIs, but with the control and the openness that only the open source ecosystem can provide. Let's check it out, how it looks right now. So if you want to start, you can just register your API key with one click. If you're ready to go right away, you can head on, immediately make a curl request, just copy the code, head to the command line. We maintain a lightweight Llama API SDK in both Python and TypeScript. Or if you're already familiar with the OpenAI SDK, you can use that directly by just adjusting the endpoint. This makes it really easy to migrate applications to Llama. If you want to just play around quickly, you can head on over to the chat completion playground, where you can play around with different models, test it out. You can change model settings, like the system instruction or the temperature, to test out different configurations. Llama 4 models are also the leading multimodal LLMs in their class. You can take advantage of this image input as well, and you can also send multiple images per prompt. If you want a structured response, you can also input a JSON schema to the model. You may also want to use tool calling. We allow you to provide tool specifications so that the model can decide when to invoke them autonomously. And this is a preview feature that we're looking to get a lot of feedback from the developer community so that we can also improve. Once you're done configuring and setting up everything, you can hit Get Code and copy from there right into your code base. And we've designed all of this with a focus on data privacy and security. Any input that you send to the API or output that you generate, we don't use to train our models.
Those are the basics. But as we talked, customization is where open source should really lead the way. And one of the ways to customize these models is fine-tuning them. The Llama API is really good at fine-tuning for your product use cases. And the best part, you have full agency over these custom models. You control them in a way that's not possible with other offerings. Whatever model you customize is yours to take wherever you want, not locked on our servers. This opens up a lot of possibilities for people that need to build and deploy custom models. Here is a quick way of fine-tuning, how fine-tuning works. You can click on the fine-tuning tab. Once you are there, you start a new job, and you upload data that is used for your fine-tuning. Or you can reuse the data that you have already uploaded. By the way, you have new synthetic data toolkits that help you generate really good post-training data for your use case. We talked about this with the Llama 3, 4, or 5B model as a distillation mechanism. There's a dev session later today if you want to learn more about it. Once your data is uploaded, a typical thing you could do is splice some part of the data for evaluation so you know how the custom model is going to do. And you configure the job, giving it a name, choosing some hyperparameters, and it's that simple. You can keep an eye on how the job is progressing, where you can look at the training loss as it progresses in real time. Once the job is complete, you get to the best part. You can go and download your custom model and run with it wherever you want. You're not locked in. Or you can run it on the Llama API, whatever is convenient for you.
OK, so you fine-tuned the model. Now you've got it ready. But how does it actually perform? So to evaluate your fine-tuned model, you head on over to our evaluation area. We fill out some of the boilerplate for you, like the job name and the model. And if you've split your data set during the fine-tuning process, we also select that by default. More importantly, you can add one or more graders that will score your model's outputs against specific criteria that you care about. For example, maybe you really care about the factuality capability. From there, you can kick off your job. It then hits our batch inference API, and we generate a bunch of model outputs and grades them. When the evaluation job is complete, you can check out a quick summary of your graders, or more importantly, you can dive deeper into the results and read them yourself. I feel like with text generation today, you just can't replace reading all of the content. Our flow is designed to be very simple compared to alternatives, which will help you understand the performance of your fine-tuned model as easily as possible.
Many startups have been testing the Llama API for a while. The early feedback we're getting is how easy it is to use, the speed and quality of responses. So that's how you build your own llamas, using the Llama API, available for preview today. But wait a second. This is only one part of the job. The second part is actually taking these custom models and running them at scale, which brings us to your favorite topic, inference.
Mono knows me too well. I mean, you've built all of these great models, but how do we actually serve them efficiently? And so when we designed Llama 4, it was with inference efficiency in mind. This is a huge priority for Meta, because Maverick powers Meta AI, and we have users all over the globe. And it's also extremely important that we've heard from all of you in the developer community. We use the mixture of experts architecture to activate only a fraction of the total number of overall model parameters. But beyond this MOE design choice, we specifically sized Maverick, why is it the number of parameters it is, to fit on a single host with FP8 weight quantization. This makes deployment very straightforward, because you can use single host inference. Although, of course, if you want higher throughput, distributed inference options are always available.
And the Llama 4 Scout model fits on a single H100, which really opens up many more possibilities for the developers. OK, so that was the model. We should also talk about the inference stack.
Yes. So we can't forget about the software we serve on. So as we moved from dense to MOE, we actually switched over to our brand new MOE runtime to power this inference stack. And we shipped a couple new features along with it. For example, we added speculative decoding. This is a technique that uses a smaller model to draft a set of tokens for the main model to use. And it will speed up token generation by about 1.5 to 2.5x. We also use paged KV to handle long queries. This breaks up the KV cache into multiple smaller blocks that can be more efficiently stored and accessed with a lookup table from a memory management standpoint. And of course, being an open model means that hardware makers can do deep integrations to deliver the best performance that you'll get anywhere. We're thrilled today to announce a collaboration with Cerebras and Grok that will help developers get even faster inference speeds with the Llama API. You can now request early experimental access to Llama 4 models powered by this exciting hardware, which is a great way to experiment and prototype with different use cases before scaling with a vendor. And to activate this, you can just select Cerebras or Grok, those model names in the API, and you'll be able to test them out and have a streamlined experience straight out of the box.
So those are the partnerships. This is what you've got to work with: the models, the API, and the Llama ecosystem of partners. The speed and the efficiency, the ability to ship by building really robust products on top of really robust infrastructure, and the power to customize the models and take them with you with full control over what you build. When you put the models, the API, and the Llama ecosystem of partners together, you can do incredible things. And we are already seeing this happen with agents that can navigate the web and use computers, with state-of-the-art performance on open source, on OCR, with open source models built on top of Llama. They are showing up every day, and it's just less than a month in. There's never been a better time to shift to open source from closed models. You get maximum flexibility, full control, and the freedom to build wherever and however it makes sense to you. It's a great time to build with Llama. And thank you so much for joining us. We can't wait to see what you build with Llama 4 and the API. Back to Chris.
All right, so when we think about where AI is going, we believe, and I'm sure many of you agree, that we're moving from textual domains to visual domains. And just like people don't learn to understand the world through reading the internet, AI will learn by seeing the world and interacting with the world the same way that we do. At FAIR, we've been very focused on building the toolkits for perception and visual domains to make it easier for folks all around the world to build the next generation of AI. We announced a few things a couple weeks ago in the open source that I wanted to highlight, starting with Locate 3D, which is a tool for labeling boundaries and objects in any 3D environment using text. This is incredibly valuable for creating data sets and building on applications on top of 3D environments. This, along with a whole bunch of our other tools, are using a perception encoder, which is a visual encoder that works well across many visual domains and is extremely portable and flexible. We're using this in a bunch of our AI tools, and we hope that many of you can too. This powers, among many other things, SAM2, the world's best object detection system for image and video, which we open sourced last fall. We've seen an immense popularity in this in scientific communities and many other visual domains. We're also using this internally for our creative tools like Instagram Edits, which we rolled out globally last week. It turns out that good object segmentation and detection is the basis for very interesting creative tools, which we're continuing to roll out. I got permission from the team to announce that SAM3 will be coming this summer. Major advancements, yeah. AWS is partnering with us to host this natively so that if you're working in a visual domain, you can just add this right in. It's super easy. It's very low latency. It's basically real time. And the innovation here is rather than pointing and clicking or labeling objects with code, you just say the thing or type the thing that you want it to label, and you'll get it instantly across the entire database. And so you'll spend less time finding all the potholes in San Francisco, which you can now just do. I hope that helps. And then the consumer use cases just sort of write themselves. I mean, you can blur all the faces for privacy reasons. You can blur license plates. Anything you can imagine where you want to take any object type and then just quickly deal with it, you can do. So we're using this a bunch internally, and we hope that you all will get a lot of value out of this too. I've been spending the last 6 to 8 weeks now driving my 10-year-old son to school and prototyping this app I showed you earlier. So we turn on the voice assistant, and I'm like, hey, you can ask it anything. And he's like, okay. So we ask about world news. It's like, do you want to learn more about tariffs? He's like, not really. That's cool, but I don't care. And so like many young people, it's just taken for granted now that you can just talk to the internet. However, he really lit up when I explained to him that he could talk to it about Dungeons and Dragons. My D&D fans are here. Okay, great. Yeah. But he loves D&D. It's like his favorite thing in the world. He's got his D&D friends. But then most other people, he don't know anything about it. So it's lost on them that he's a level 4 druid. And of course, he dives into the conversation, and it's an assistant that knows everything about D&D. And it could immediately pop back with okay, what's your subclass? What's your dexterity modifier? I may be getting this wrong. And it's cool because that's for him when the light bulb went off. It's okay, this is a very specific niche interest that I have, that I'm deep on, and now I'm actually able to go deep in an ongoing way with something that gets it, and that is sort of imbued with all of the wisdom and understanding of the internet on this specific topic. And I think part of what's so fun and interesting right now about the field is those light bulbs are going off for a lot of people in a lot of different domains and verticals, as people out there are starting to wrap their heads around the power behind these systems once you get past sort of the first chapter. So we are very, very, very excited to be hosting you all today. Thank you for making the trip out here. There's a great lineup for us to understand better what we can do to serve you guys. We really appreciate you building with us. So have a great LlamaCon. And then coming up after just a short break, you're going to have Mark and Ollie from Databricks, who are going to walk you through what they're working on. All right. Thanks, everybody.
Please welcome Meta founder and CEO Mark Zuckerberg and Databricks co-founder and CEO Ollie Gotzi.
All right, welcome to LlamaCon. Good to see all of you guys. All right, so went through some of the new stuff with Chris a minute ago. That was awesome. Now I'm excited to have a conversation with someone who's been a great partner and really someone who's been working on open source since the beginning of your company, right? With Databricks. You guys do all the data management. Obviously now AI has become increasingly important to everything that you do. From the early days, you've embraced all of the different open source approaches to this, and have really been great at building an implementation that just makes it super easy for enterprises and developers to get started with a lot of these different things. So you kind of have this front row seat to this, and I'm glad that you're here to tell us about kind of what you're seeing. What are the big trends? There's obviously a lot of new directions for the technology, a lot of new inventions that are kind of coming out. But I'm curious, both what you're seeing is getting the most traction, what are the most exciting trends, and what you think are on the horizon that you're most excited about that your customers are seeing. And we can start there and just go whatever direction makes sense.
Awesome. Yeah, thanks so much for having me. Super excited about this. It's an awesome event. It's just the rapid progress is crazy. I think we kind of maybe lose sight of it. I think the most impressive thing is, I think Llama 3.1 was a year ago, last year.
A little less.
Yeah, and that was 405 billion parameter model. And then soon after you guys released 3.3, the 70B model was just as good as the big one. So it's you get these smaller and smaller models that are better than way bigger model a year earlier. And that just unlocks lots of new use cases, because that puts pressure on price. Prices come down, and that unlocks new use cases that were just not possible before. New architectures. So we are super excited that there's a mixture of experts, because that again lets you go faster and cheaper with more intelligence. So that again unlocks a lot of use cases. So that's super cool to see. The context length getting bigger and bigger. That also unlocks new use cases where you can just put whole things in the context of these models. So there's just coding. I'd be missed to not mention that.
Yeah.
I would say just a year or year and a half ago, software engineers were not really affected by AI. And now it's just completely transformed what people are doing. And then, of course, we have agents. So, could go on and on.
Yeah, so are there any particular success stories that you're seeing from developers who are using Llama or any of the other open models on Databricks that you think are kind of inspiring and interesting to share?
Yeah, there's thousands, tens of thousands, if not even more.
Let's go with two.
Okay, all right, two. All right. One that I like is Crisis Text Line. And Crisis Text Line, what they do is they use Llama, and they've customized it to be able to sort of detect, people who want to do self-harm or suicide, and they can detect that, and it can sort of help people that call into their lines. And, it's all, it can detect what's going on. It can give you sort of risk scores. I think just last year, they've had over millions of conversations with people, that were in crisis situations. Thanks to it being open source, you can also customize these. It gives you opportunities. Like at Databricks, we can develop techniques that really can customize it and let them monitor and kind of improve the quality so that you get those. Because, that's an important use case. You don't want to get things wrong. So accuracy is really, really important. You don't want to have false positives. You don't want to have false negatives. So I think that's something that would not have been possible a few years ago. Another one on the more business side, enterprise side, that's really interesting is, people have been using these, FactSet terminals, like FactSet, Bloomberg terminals, things like that. And on these, you have to analysts type in these queries over the last 20 years, FactSet query language. So if you want to see how stocks are doing, you have to enter these complicated things. Well, with Llama, now they can just ask in English. They can just say, hey, how's the earnings per share for this particular stock compared to this, bond, this and that? And it just produces the code for it. And that was just not possible before. So it just opens up a whole new market for FactSet. So just two things that have been completely impossible, let's say 3-4 years ago.
Yeah, interesting. What about some of the new capabilities that have come out, right? So obviously the model architecture for Llama 4, the first two models around Scout and Maverick, were designed to be very low latency, very efficient. That's why we chose 17 billion active parameters, and it's and the context window length was a big thing that we focused on. What are you seeing in terms of novel things that people are doing? I know it's still early days, obviously, but I'm curious what you're seeing around all that.
Yeah, I mean, there's so many different techniques. The most important thing we're seeing is, especially for developers, is do you have some access to some special data? If you have access to some special data, there are just so many things you can do. Number one thing is, if you can get the evals or benchmarks right on these models, then you can get into this iterative improvement loop and start tuning the model. So like one thing we did at Databricks that would not have been possible if Llama was not open source is we developed this thing called Tau, which is we can do reinforcement learning on our customers' data and make the Llama model really understand the custom data and reason on the custom data that each organization has. We call this data intelligence. This kind of reinforcement learning technique would have not been possible if Llama was not open source. Like if we were using any closed source model, we couldn't do that. So things like that open up because the model is open source is a big deal. The context length, this is early days, but it's really interesting because people are using all kinds of hacks, using vector search, they're embedding documents into these and so on. If you can just take all of your relevant data and just put it in the context, and then Llama can just figure out what's relevant for it, that's also a game changer. So excited about that direction as well. But I do think the MOE, the mixture of experts, is probably the biggest change because it just lets us lower the price so much. A lot of enterprises have use cases where, every night, hundreds of gigabytes of PDFs come in. And we want to just extract all this information from the text automatically, which, by the way, also includes vision, right? It needs to be able to understand other modalities than just text. It needs to extract pictures and things like that. And now you can just, you want to run that every night. And it's like lots of documents. So the price matters a lot because these are big data sets. Mixture of experts lets you just cut that price down because it's just using much fewer active parameters when it's running. So these are all things that would not have been possible, like even with Llama a year ago, and now we can do it.
Yeah, so and obviously your wheelhouse is really around all the data stuff and combining that to customize. And one of the main pieces of value around open source is that you can fine-tune and customize the models however you want. So I'm curious what you're seeing in terms of how developers are making really good use of the open source models to combine it with whether it's RAG or different ways to do fine-tuning to kind of build custom models. Distillation is another thing that I think has really emerged over the last year is like a really important and valuable way to basically take a larger model and then basically suck most of the intelligence out of it into whatever form factor you need. But I'm curious what you're seeing people do around that whole set of things, that around kind of like basically customizing, building your own things, combining it with the data that they use for all the rest of the Databricks services.
Yeah, I mean, I'll tell you the most surprising thing for me that I saw from Llama is like, okay, you guys put out the bigger ones, they're super smart, and we're like, oh, as a company, we're going to make a lot of revenue on the big models. But the biggest surprising thing I've seen is they distill down and they use the smallest possible, humanly smallest model they can find. So
yeah,
actually,
the most popular Llama 3 model was the 8 billion.
Yeah, 8 billion.
And we'll build, I mean, we released the Scout and the Maverick ones, right? The 17B experts by, how many of our experts. But we're working on the big ones. We talked about Behemoth, but we're also working on our internal, I don't know, the temporary code name is Little Llama, but we'll see what we actually end up calling it. But I think that's going to end up being a really popular thing too. Yeah.
Yeah. I think the smaller ones, I mean, the big ones are important because they have the intelligence and people are using Databricks to distill them down. And yeah, you're right. They use RAG. They put the relevant data in there. They use both what they have in the RAG in the vector database and what the bigger models have. But ultimately, their goal is like, hey, so this seems to be kind of like the quality of the frontier I can get with the bigger models on Llama. Now I want to distill down the smallest possible for this particular use case. And the cheaper I can make this, the more important, because I'm going to hit this like, billions of times every day. So like the smaller I can make it, the better. And yeah, you're right. With distillation, you can, for that particular use case, get the tiny model to have the same intelligence as the biggest ones. Not on everything, but most organizations, they don't want to do everything. They want to like do this thing repetitively again and again. It's just like jobs. Like we don't do everything in a job at work. People are specialized and they do something, repeatedly.
Yeah. So do you have a sense on where the sweet spot is on that, or is it shifted over time?
sweet spot on the
Yeah,
size?
size, yeah, for the model architectures.
Yeah, I mean, the smaller, the better, honestly. Like, you know, because it's a cost thing. You know, they keep pushing. Like, I think the smaller you can, so the question is just how much can we compress the AI down? So a lot of organizations are thinking like this, okay, I have this repetitive task. What's the frontier SOTA, so state of the art? Okay? And now do that as cheap as possible. Who can do this, or can I distill the cheapest possible? And I don't think there's like a, you know, oh, we don't want to go below 1 billion parameters or so on. No, if you go even further, you know, we have a lot of customers that are doing coding. And for coding, you know, you want to have, you know, as you're typing, you want it to code ahead and write ahead for you. There you want, that latency is super important. So even a few billion parameters might be too big, you want it to quickly do autocomplete, like, you know, milliseconds count. So I think there's going to be a continued race for like, okay, frontier big smart models, which you guys are doing, and then this, like, I'm looking forward to the, what did you say, small llama?
Yeah, little llama.
Little llama, yeah, little llama. Looking forward to little llama. I hope it's really small. And tiny llama and, you know, mini llama and whatnot.
There's always a smaller llama.
Yeah, exactly.
Yeah. Yeah. Interesting. So yeah, I mean, a big part of how we designed and chose the model architecture for the 17B expert size was around latency, but not like that kind of extreme latency. We're talking about, I mean, a big theme for us, and you guys might have seen, we just dropped this Meta AI app this morning where there's almost 1 billion people using, or monthly actives at least, using like Meta AI across our different apps. And you know, a lot of people using it on a daily basis, but we figured it would be useful, and some people would enjoy just having it as a standalone app. One of the big themes in that is voice, which I think is going to be an increasingly important paradigm for how people interact with these models, and that obviously requires really good latency. So I mean, that's one of the things that we've been thinking about. It's maybe a little bit different from type-ahead type latency, but you obviously, when you're done speaking, you want it to be able to respond very quickly, and you want it to be able to kind of jump in. So I think the latency thing and cost is definitely a big part of this. And
100%.
A lot of how we've tried to design these are, you know, obviously we want to be able to deliver kind of the highest level of intelligence, but I think most folks who are running applications at scale really care about the intelligence per cost, or the intelligence per kind of compute cycle, because you're just constrained on scaling this stuff. So that definitely makes sense. And I mean, obviously we're a little bit less in the enterprise context than you are, but it's good to kind of hear that that's consistent across.
It's spot on. And you're right. The voice use cases are just massive. You know, there's just organizations out there, millions of companies out there. You know, they interact with their customers mainly through voice.
Yeah.
So yeah, it's super exciting. I think that's going to be one of the big modalities that's going to be a game changing. You know, I mean, why do you need even a keyboard in the future? Why type? I mean, we're not typing to each other right now.
I think text will remain. I think you and I probably communicate a little more over text than we do by calling each other, although we call each other a bit.
That is true, but do we have to type?
When there's someone else in the room, it's helpful.
That's true. That's true.
But no, I mean, I generally agree with your point. I think that I think voice is kind of under indexed today. I mean, my understanding is basically the mix on this is it's today in terms of this type of AI use, it's maybe like 95% text or more. And I do think that over time, you know, especially as more people get like wearable, like the glasses that I'm wearing, right? It's like you just like throughout the day, I think you're just going to be talking to AI and kind of all these subtle ways and get interesting context from that. And so I think voice will be a lot bigger than it is today.
100%.
Yeah. All right. So open source. Let's talk about your kind of your history on this and how you see this whole thing developing. I mean, this really has been a part of Databricks and your DNA from the beginning. You've been a huge proponent and someone who I've bounced a lot of ideas off of when, you know, I'm trying to think through what should we do with Llama and like how should we approach this. I mean, you've kind of been an important advisor and partner to me and Meta on figuring this out. But I'm curious how this kind of open source is obviously bigger than just us, and I'm curious how you think. How does this tie into your vision for what you're trying to do with Databricks, and where do you think kind of the ecosystem is going overall? And now that we're getting this well, maybe I'll stop there and then I'll ask more questions after.
Yeah, I think that's awesome. Yeah, I mean, we're big believers of open source, ever since the Apache Spark days from the beginning. I think the most important thing is that, first of all, it just puts pricing pressure on this stuff. I think people are not taking that into account, that, price of, serving large language models or VLMs, is where it is today, a large part thanks to Llama. Because, it's just, it's like anyone can take that model, serve it themselves with, Llama CPP. They can even run it on their CPU. So that immediately, drops that price. And that just means it unlocks a lot of use cases for a lot of organizations out there, where if this would, the price has been dropping continuously on this stuff. So
yeah, and you see it. Every time we do a Llama release, all the other companies drop their API prices.
So I think that's a game changer because, it just unlocks. It's a supply and demand thing, right? So now when the price is lower, you just now have much more demand for this stuff. It unlocks so many new use cases that would not be possible before. So I think that itself is huge. The second is, all these universities, all these researchers around the world that, want to work on AI, they kind of can't use these closed source models. They're kind of blocked out. Actually, I work part-time at UC Berkeley, and, it's like, at the universities, the mood is not great around AI because they feel like, hey, we're kind of locked out. We don't have access to the weights of these models. We can't do anything. So Llama's been a game changing for them because now they can actually start using all these techniques and they can come up with new ways to do things, new ways to fine tune or add reasoning and so on. So I think that's actually really game changing, on the whole planet, right? If it's closed source, it's just that one company that has it that can, we have to just depend on them doing research on it. When it's open source, you get this sort of open research and open sharing. You get sort of a whole world working on these models, and you just have much, much more rapid progress. So I think that's really important. And then, of course, there's the usual thing with open source, which, so this was specifically to LLMs, but with open source, you, of course, get this community of people using it, and you build up this ecosystem around it. And that, I think, is invaluable, and we see that already. There's people are just super excited to mix and match the different models, and there's a lot of cross-pollination between all these different models that are being put out there. If you track local Llama on Reddit or something like that, you can just see people are doing crazy things, slicing, putting the models together, getting better results. All of this completely impossible if it wasn't open source. So I actually think that there's going to be a continued race for open source models, and we're going to see them continue sort of being at the frontier. In fact, I've kind of joked and said, in the future, I think when it comes to sort of model business, like model API business or serving these LLMs, every model will be open source. You might just not know it yet, because there's distillation, there's all this sharing this stuff. So I think in the long run, everything's going to kind of go towards open source. And I think you guys were a big reason, if not the main reason, why that's happening. Because you put that out there and you put that in the forefront and pushed for it.
Yeah, no, it's been really gratifying to see the industry move in this direction. So I'm very happy that that is happening. You mentioned distillation, and you mentioned other models. And I think it's worth spending a few minutes on this, because to me, one of the most valuable parts of open source is not just that people can take the models and use them and customize them a little bit, but it's you can really take it and distill it into whatever you need it to be in whatever shape you need it to be. And I think one of the most interesting things over the last year, if you kind of rewind a year, Llama was really the main and kind of only at that point major open source model, and now that's not really the case. Now there are others as well. Llama, I think, still leads in many areas, but I think the reality and part of the value around open source is that you can mix and match. So if another model, if DeepSeek is better, or if Qwen is better at something, then now as developers, you have the ability to take kind of the best parts of the intelligence from the different models and produce exactly what you need, which I think is going to be very powerful. But it means that there's an even more important place in the ecosystem for companies like yours to help build these distillation tools. And I'm curious how you see that going, because I just think that this is part of how I think open source basically passes in quality all the closed source, is that you don't just have to choose one model off the shelf and then either customize it or distill off of that base. You get this just increasing mix of being able to just pick the parts that you want from an increasing number of open source models. And it honestly, I mean, it feels like sort of an unstoppable force, but it really does need the infrastructure that companies like yours provide in order to provide that. So yeah, I'm curious how you think about that and where you think that's going and what technology needs to get built to really enable that and that whole theme.
Yeah, I think that's spot on. When DeepSeek came out, a lot of folks, a lot of the customers that we had were like, oh, well, the model was produced, in China. Can we really use it? The weights were, baked there. But the most common model people were using on Databricks were actually the Llama distilled DeepSeek ones. So, where you took the R1 reasoning and you distilled it on top of Llama. So they were actually using Llama. So it was really the Llama model. And by the way, the beautiful thing for us was we could just launch it immediately because it's just Llama. But we distilled the reasoning from R1 on top of it. It was super popular. It actually became one of the most popular models that week when everybody was talking about DeepSeek coming out. So things like that. So it's the mixing and matching, as you said. Like we all see these models come out, and there's like all these benchmark results. Like, oh, it's really good at programming this, or Math Olympiad that, or function calling for enterprises, and so on. These are all sort of characteristics and capabilities that different models have. We're seeing lots of mix and matching. So like, okay, can we create traces on how well it does this particular aspect, this model, and can we then overlay it and distill it and add it on top of a model over here? That's basically what people are doing on Databricks. They're basically mixing and matching these. And that's why you're seeing this convergence of all the models, right? People are like, oh, it's like saturating or it's converging. Well, it's because people are mixing and matching. Again, this would not be possible without open source. With open source, you can just do that. And there's so many techniques you can use, especially if you want to do things like reinforcement learning. And I think actually things are accelerating now in the reasoning space, this inference time compute, where you're doing thinking and using the thinking traces to generate models that have these sort of thinking capabilities and they can become really good at specific tasks. That seems to be even more, much more than a year or two ago, amenable to distillation. It was like a Berkeley research paper that showed that for $450, they could get, the reasoning traces from like the best reasoning models and apply it to any model for $450. So I think you're right. The distillation, especially in this reasoning, inference time, compute era, is extremely powerful, and I'm not sure everybody's kind of realized that. But
yeah, no, and are you seeing that in your usage and customers? Is the amount of usage of the distillation tools increasing at a faster rate than just kind of usage of the APIs to access intelligence, or which of these type of phenomena are growing faster among your customers?
Yeah, I mean, as I said, the most surprising thing a couple of years ago was why people are using the smallest model. So I was like, oh, that's surprising. The second big trend that happened is, I would say, last year when sort of inference time compute or test time compute switch happened, the market shifted to lots of distillation of these traces to really make the model spike in certain dimensions. Like, I really needed to do this really well. It's kind of a shift. Before that, it was like you kind of pick one big model and you use that, and there wasn't that much fine-tuning and so on going on. With the reasoning time compute, it's accelerated. So you can clearly see there's like a behavioral shift where it's just, get traces, tune on those. And then, of course, the popularity of this technique called reinforcement learning, which we saw very little of like 3 years ago or 2 years ago. Now everybody's want to use those reinforcement learning libraries. They want to apply various techniques of so on top, and they're looking for verifiers, like problems where we know what the correct answer is, and they're trying to make the models really, really good at that. Or problems where if you could make this go faster for me, I would, that would mean a lot for me. Because then, there's a correct answer. We know what the answer is. You just need to make it faster and faster. So there's a lot of use cases like that where people are just sending off these LLMs to get them to do something. Like write software for me that, can do this task faster and faster and faster than before.
Yeah. The point that you mentioned a few minutes ago around having access to the reasoning traces, I think is a really interesting one. It's something that we've been thinking about a bunch because there's this whole question around open source where it's like the models are open, but the data isn't for a number of reasons, including that like a bunch of it comes from our services, and we don't, like not going to share that. But with reasoning, it's sort of a different story, right? Because the way that you train the reasoning models is using these problems that have verifiable answers. So if you're giving it hard math problems or hard coding problems, the data there is much less proprietary.
Yeah.
And I think that this is potentially an interesting thing to explore, is allowing kind of new types of open source that's not just the weights of the model, but also potentially some of the reasoning traces. The other thing that I think is going to be important around this is we're talking about distillation, how powerful it is, but I do think that there's going to be this whole theme around how do you do distillation in a safe and secure way, right? Because especially, I think a lot of people are going to have questions about, okay, you're using models that are coming from different countries or different places that you don't know as much about. Like, how do you make sure that you're not inheriting security vulnerabilities or kind of different values that are kind of problematic that you don't want to have in your model? And that's another area where I just think that having one of the key tools around that, I mean, obviously we've built stuff like LlamaGuard and we've built Code Shield and we've open sourced all of that, but having the reasoning traces be able to be open is going to be, I think, one interesting thing that we're thinking through for how you can do the reasoning models in a good way going forward. But it's still just a thing that we're thinking through. But the distillation thing, I think, is going to be a really big deal, and just increasingly so as you get into this world of different models.
Yeah, we'd love to see it.
Yeah.
You know, nudge, nudge. Like, we'd love to see those traces. We'd love anything in the space where we can sort of, and LlamaGuard is a big deal. You know, there was one organization that came to us and said that, you know, they had built a chatbot, and when you interrogated it, you asked it, like, what's the best car? It would recommend the competitors' cars, you know? So, like, things like that is not great. So, yeah, you're right.
It's a tough break. Yeah.
I mean, maybe the model is smart, you know?
Yeah.
Maybe it's right.
Well, I mean, it does speak to this other part of the future here, is I think, you know, a lot of the big companies kind of focus on the development of, like, one AI assistant. Right, whether it's, I mean, and we have Meta AI, so we have ours too. I mean, it makes sense. There's going to be like, you want across your services to have some assistant that people can use. But, I mean, part of the open source vision is just this belief that there are going to be many, many different AIs, right? I mean, like on the business side, one of the big things that we're working on is, like, we just believe that, like, all right, there's, you know, of the more than 100 million small businesses that use our services, like, we think that basically every one of them is going to want to have an AI agent that could do customer support and sales for them in WhatsApp and messaging apps. And similar to what you're saying, a business is not going to want their AI agent to sell their competitor's product, right? So I think that there's like just this basic agency question, which is, okay, that's why that to me is like an existence proof of, okay, there's obviously going to need to be many of these things, because, you know, like a business isn't just going to want to point someone to Meta AI or Gemini or whatever if it might sell their competitor's thing. They're going to want a custom thing for themselves.
Yeah, I think people are super excited about agents. Yeah. Obviously, the quality is the thing that is right now the focus of everyone. How can we get the accuracy to a level where we can just depend on them? Because, you know, they do mistakes still. Like, I think the industry is at a level where still, like, the quality isn't quite there for most tasks.
Yeah.
But it's, you know, once we get there, and since these agents are doing a lot of reasoning, it might actually take them a while to get stuff done. So then you want to have a lot of them. So you're right about the diversity. You want to have like lots of, probably we'll have humans supervising lots of these agents. So it leads to even more proliferation of these, and you have the variety of those. And then, you know, your job is to supervise and make sure that they're not, you know, veering off doing the you know. So I still think there's like human in the loop right now. But yeah, I would say like among our customer base, when we talk to customers, their number one thing people are excited about are agents. You know, agents and coding is like the two big things that everybody's sort of investing heavily in. And of course, Llama's front seat there.
Yeah, makes sense. So, all right, so we got a few minutes. I'm curious just to transition to just general kind of what advice do you have for the developers who are here as they're thinking about building you know, all these different things with AI? Like, how would you think about this? Like, what, general advice, like what are the most kind of, let's start there, and then we can maybe.
Well, I mean, first of all, I think it's like day zero of the AI era. So I think it's super exciting. Like, people are like, oh, it's moving so fast, and maybe I'm behind, and I'm missing the latest things that are happening. No, it's like, I think the most amazing applications are yet to be invented, right? You don't need to be, you know, I mean, like, if you go back to like the beginnings of the internet, like, you didn't need to have to be expert on how routers work and, you know, protocols and whatnot. Like, you know, you came up with ideas like Facebook, or people came up with, you know, ideas like Airbnb and so on. Like, those are completely different. So I think, you know, anyone here in the audience, like, you know, this is a complete white space. There's so many such ideas that we have not invented yet. So explore these models, use them, I think the most important thing is going to be the data. Like, do you have a data advantage? Do you have some data set that you can get and, get these models? Since they're open source, you can tune them, you can do distillation, as Mark said, and you can build use cases where the model really excels on that particular data set that you have. And if you can figure out a flywheel, if you can figure out a network effect where you can sort of start collecting the data and the model gets better and better at it, kind of like Facebook in the early days, then you're onto something really exciting. And I think there's going to be thousands of applications that we can't even think of right now. Just like in 2000, when the internet came about, we could not have imagined Facebook or Airbnb. We didn't even. In fact, it took so many years. Just Airbnb was 2009, I think, right? Why did not come about much earlier? So it takes a while. So all those future applications, they have not been invented yet, and people in the audience here, people worldwide, using these open source models can actually build those. So I think it's very, very exciting times. But it comes back to that data flywheel and evals and benchmarks, because I think there's a focus on how is it doing on Math Olympiad, or how is it doing on programming contest. But it's really for those use cases you want to build, those applications that have not yet been invented. Can you build an eval that really evaluates that? Because you're not going to sit there and look at every prediction or every word or token that the model is producing. So we have to automate it somehow. So it's coming up. I think evals and data sets are going to be super important, and then customizing these models to become really, really good at whatever use cases you have in mind. So try it out, use it, explore those crazy new ideas. It's going to be exciting times ahead, I think.
Awesome. All right. I think we're pretty much at time, but any closing thoughts or anything else you want to add for the group?
No, this is super exciting. We're super excited to continue, using these models, customizing them, mixing them. Thank you for open sourcing it and pushing, open research, open source.
Thank you for being an awesome partner on this, and you guys do great work. Really appreciate working with you, and thanks for helping push the ecosystem forward.
Thanks, Mark.
All right. Thank you all.